Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the concept of time division multiplexing. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the concept of spread spectrum technology. First of all, we have to know that what is meant by spectrum. We know that in communication we transmit information from one point to the another point. Okay, the information may be in the form of digital or analog. Okay, digital or analog, and this information have the range of frequencies. This range of frequencies is known as the bandwidth. Okay, we already seen this concept. The information has the range of frequencies, and this range of frequencies is known as bandwidth, and this range of frequencies is known as the spectrum of the signal. Okay, I hope you all understand what is meant by spectrum. Let's see once again. The range of frequencies occupied by the information signal or the total signal is known as the spectrum of this signal. Okay, now let's start our topic. The spread spectrum is defined as a wireless communication technology that uses more bandwidth than is required to deliver information. That means the spread spectrum technology is a wireless technology. That means this technology, or in this type of communication, a antenna is used to transmit the data. Okay, I hope you all understand the wireless technology. That means wireless mean in this type of communication no hardwire is used. Okay, or no optical fiber is used. The transmission is done through this space by using the antenna at the transmitter and at the receiver. Okay, and in this technology, this technology uses more bandwidth than is required. That means if to transmit any information, if this type of band is required, then in this spread spectrum technology it uses more bandwidth. That means it uses this type of bandwidth. Okay, let's see next point. The spread spectrum techniques are the methods by which the signal generated with a particular bandwidth is deliberately spread in the frequency domain, resulting in the signal with wider bandwidth. That means in spread spectrum technology, if this is the frequency domain and this is the desired information to be transmitted, and this is the bandwidth of the signal, then in spread spectrum technology this bandwidth is deliberately increased. Okay, that means this bandwidth is increased in the spread spectrum technology. The spread spectrum is a technique used for wireless communication, in telecommunication and radio communication. That means the spread spectrum technology is mainly used in the telecommunication and radio communication applications. In spread spectrum technology, the original data signal is multiplied with a pseudo-random noise spreading code. We have seen the pseudo-random noise spreading code in the next lecture. Okay, the spread spectrum uses wideband noise-like signals that are hard to detect, intercept, or demodulate. Additionally, spread spectrum signals are harder to jam, that means interference with, than the narrow band signals. That means, in short, we can say that the spread spectrum technology can be used for the security purpose, and it is very popular in the military applications. Okay, that means in military applications, the information signal is very secure or the highest priority. This information should not be acquired by the enemy. For that purpose, this information requires highest security, and this highest security is given by these spread spectrum techniques. Let's see the concept of the spread spectrum Here is the original information which has the bandwidth. In spread spectrum technology, the spreading process is done. That means the bandwidth of the signal is increased. Okay, I hope now you all understand what is meant by spread spectrum. That means in spread spectrum technology, the bandwidth of the signal is increased. Okay, now let's see the basic technique spread spectrum technology block diagram. This is the basic block diagram. Okay, in this block diagram we can see that this is the transmitter block and this is the receiver block. In transmitter there are number of blocks such as channel encoder, modulator and pseudo-random pattern generator. In a receiver the opposite blocks are used. That means here modulator used, hence in receiver demodulator is used, channel decoder is used, but the one block pseudo random generator is common in both transmitter and receiver. The only condition is that these both are must be synchronized with each other. Okay, let's see the details about each block one by one. First of all, channel encoder. The channel encoder adds some redundant bits to the input bit sequence in properly defined format. Okay, the next is pseudo random generator. It produces pseudo random or pseudo noise binary valued sequence. Next is modulator. Pseudo-noise binary valued sequence is impressed on the transmitted signal at the modulator. That means in the modulator, the encoded signal and the pseudo-random noise or the pseudo-random signal is mixed together or superimposed on each other and transmitted through a channel. Okay, we know that the channel is a medium through which the signal travels towards the receiver. Consider or remember here that this channel is of wireless type. Okay, that means it may be in radio frequency wave or electromagnetic wave. Okay, I hope you all understand this channel is in the form of electromagnetic wave, and for this electromagnetic wave we require antenna at the transmitter and antenna at the receiver. The next is demodulator. The impressed pseudo normal sequence removed from the received signal at the demodulator and the channel decoder is used. The decoder at the receiver uses the coded bits to reconstruct the error free accurate bit sequence and reduce the effect of the channel noise and distortion. This is the basic block diagram of the spread spectrum technique. Okay. Now, the very important point in this video is the types of spread spectrum techniques. There are mainly three types of spread spectrum techniques: direct sequence, time hopper, and frequency hopper. Out of these three types, the direct sequence and frequency hopper is very popular. Okay, there are two types of direct sequence, wideband and narrowband, and there are also two types of frequency hopper, that is slow frequency hopper and fast frequency hopper. Let's see the details about the first type, frequency hopping spread spectrum technique. Okay, the frequency hopping spread spectrum is a method of transmitting radio signals by rapidly changing the carrier frequencies among many distant frequencies occupying a large spectral band. That means there are the number of carrier frequencies, and in frequency hopping technique it transmits the radio signal by rapidly changing these carrier frequencies. Okay, in frequency hopping spread spectrum, the technique uses m different carrier frequencies that are modulated by the source signal. Okay, in short, we can say that in frequency hopping system, there are many different carrier frequencies are used to modulate the source signal. At one moment, the signal modulates one carrier frequency. At the next moment, the signal modulates another carrier frequency. Although the modulation is done using one carrier frequency at a time, hence m frequencies are used in the long run. The bandwidth occupied by the source after spreading is BPHs must or more greater than the bandwidth of the modulating signal. Okay, let's see the algorithm of FHSS, that means frequency hopping spread spectrum technique. First of all, let's consider the algorithm is for the transmitter and the receiver. Okay, and the transmitter transmits the data through the electromagnetic wave towards the receiver. Then what is the actual process done during this transmission or during this communication is known as the algorithm, or the proper sequence is known as the algorithm. Let's see the first, the initiating party, that means the transmitter, sends request via a predefined frequency or the control channel. Okay, that means the transmitter first sends the request. This is the known as the process known as for the synchronization process. Okay, once the receiving party have received the request, it sends a pseudonormal number called seed to transmit the party via the same channel. Okay, that means when the transmitter transmits the request, the receiving party, that means the receiver, received the request and transmits a pseudonormal or the pseudo number called the seed towards the receiver. Okay, the initiating party uses the seed as a variable in predefined algorithm and calculates the sequence of the frequencies that must now be used to transmit the signal. For example, that means the transmitter now uses the seed and transmits the data. The initiating party then sends the first piece of information via the lowest band of newly generated frequency spectrum. The communication begins, and both the receiving party and the sending party changes the frequencies along with the calculated order starting at the same point. I hope you all understand this algorithm. In short, we can see the application of this spread frequency hopping spread spectrum. The application of this system is our Bluetooth system. Okay, we all familiar with this Bluetooth system. Okay, what happens in Bluetooth system? If we want to transmit some data from our mobile 1 to mobile 2, then what are the process? First of all, both the mobiles should on their Bluetooth. Then the mobile 1, if we want to transmit data from mobile 1 to mobile 2, then first we have to pair these two devices, mobile 1 and mobile 2, by sending a data or sending a number. Then after pairing, the transmission begins. Okay, this is the Bluetooth is the example of FHSS system. I hope now you all understand this system. Okay, let's see the graphical representation of this system. In frequency hopping, the data is divided into the different chunks and is transmitted at the different frequencies at different times. Here is the graphical representation of frequency hopping spread spectrum technique is shown, in which we can see that at the first instant the frequency of the carrier 700 is transmitted. The second instant the frequency of 900 is transmitted. Third instant the 300 kilohertz frequency is transmitted, and so on. After completing one cycle, the process repeats. Okay, that means the original signal is modulated at the first instant at the carrier of 700 kilohertz. At the second instant, the modulating signal is modulated with the 900 kilohertz carrier. At the third instant, the modulating signal is modulated with the 300 kilohertz carrier. Okay, and the process continues, but the only condition is that the transmitter and the receiver should be synchronized with each other. Okay, I hope you all understand. Let's see the frequency hopping spread spectrum transmitter. This is the block diagram for the transmitter, in which we can see that there are number of blocks such as FSK modulator, mixer, frequency synthesizer, pseudo random code generator, band pass filter, and RF power amplifier. Let's see the details about them one by one. The binary data, that means the data to be transmitted, is applied to conventional two-tone FSK modulator. Okay, here consider or remember here that this FSK modulator is of two-tone FSK modulator. That means the output of the FSK is of two-tone frequency. That means in short we can say that there are two frequencies. Okay, the modulator output is applied to the mixer. Okay, the synthesizer is driven by the digital circuit known as the pseudo random code generator. Okay, that means this frequency synthesizer is driven by this block. The pseudo random code is serial pattern of binary 0 and 1 that changes the random fashion. Okay, these two signals are mixed together in a mixer and the mixed signal are given to this band pass filter. The output of the band pass filter is the difference between the two FSK sine waves and the frequency of the frequency synthesizer. Okay, that means the output of the mixer is the combination of the FS the one of the two sine wave of this FSK modulator and the frequency synthesizer. Okay, now after band pass filter through RF power amplifier, the signal is transmitted towards the antenna in frequency hopping spread spectrum. The rate of synthesizer frequency is change is higher than that the data rate. This is the main requirement of the system, is that the data rate of the frequency synthesizer should be higher than the serial binary data rate. Okay, I hope you all understand. The time that the synthesizer remains on a single frequency is called as the dwell time, or in short we can say that the time for which the frequency synthesizer remains on a single frequency is known as the dwell time. As per Federal Communications Commissions, that means FCC regulations specifications, there should be minimum of 75 hopping frequencies and the dwell time is not exceeded than 400 microsecond. Okay, now let's see the graphical representation of frequency hopping spread spectrum transmitter. In this waveform we can say that there are two waveforms, serial binary data and this pseudo random rate. Okay, in which we can say that for 1 bit interval there are 4 pseudo random noise or pseudo random code each generator. The illustration above shows that the frequency synthesizer changes 4 times of each data bit. The time spent on each frequency is called as dwell time. That means this time for each bit is known as the dwell time. It is typically less than 10 milliseconds. Okay, now let's see the block diagram of frequency hopping spread spectrum receiver. Remember here that whatever the process done in the transmitter, the opposite process is done in the receiver. The wideband signal is picked by the antenna, then it is fed up to a broadband RF amplifier and mixer to the IF amplifier as shown in the figure. The receiver mixer is driven by the frequency synthesizer, which is driven by PSN code generator, same as in FHSS transmitter. Okay, this block is works as same in the transmitter. The frequency synthesizer at the receiving must be synchronized with the frequency synthesizer of the transmitter. The signal is reformed through an IF amplifier. That means this signal is mainly reformed through this IF amplifier to obtain the original FSK data, and the FSK demodulator is used to reproduce the original signal. I hope you all understand the transmission and the reception process. Okay, there are mainly two types of frequency hopping spread spectrum, slow frequency hopping and fast frequency hopping. Let's see the difference between them. In slow frequency hopping, more than one symbols are transmitted per frequency hop. In fast frequency hopping, more than one frequency hops are required to transmit one symbol. In slow frequency hopping, chip rate is equal to symbol rate, while in fast frequency hopping, chip rate is equal to the hop rate. In slow frequency hopping, the symbol rate is higher than HOP rate or hop rate. In fast frequency hopping, the hop rate is higher than the symbol rate. The fourth point in slow frequency hopping is that same carrier frequency is used to transmit one or more signal. In fast frequency hopping, one symbol is transmitted over a multiple carriers in different hops. In slow frequency hopping, a jammer can detect this signal if the carrier frequency in one hop is known. In fast frequency hopping, the jammer can't detect this signal because one symbol is transmitted using more than one carrier frequency. Okay. Now let's see the transmitter and receiver of frequency hopping spread spectrum once again. In this diagram, we can see here that the serial binary data is given to the FSK modulator. Remember here that this FSK modulator is the two-tone frequency modulator. That means the output of this frequency modulator contains the two frequencies having the two tones or the two sine waves having the two frequencies. Okay, this is given to the one input of the mixer. The another input of the mixer is obtained from the frequency synthesizer and which is driven by this pseudo random code generator. This code generator is or this code is at higher rate than the serial binary data. This combination is given to the band pass filter which filters the specific band and is given to the RF power amplifier for the transmission through the antenna. At the receiving end, this data is received by the receiving antenna and it is given to the wideband RF amplifier to reproduce the signal. Okay, this is given to the mixer and this mixer's output or this mixer's another input is from frequency synthesizer which is driven by the PSN code generator. Okay, these two blocks are identical in both transmitter and receiver. Okay, the only condition is that these two blocks must be synchronized with each other. Okay, then the mixer output is given to the IF amplifier. IF amplifier reproduces the FSK signal and this FSK signal is given to the FSK demodulator to produce the original signal serial data. Okay, this is the total process done in FHSS transmitter and receiver. I hope now you all understand this all process. Okay, now let's see the advantages of frequency hopping spread spectrum. There are number of advantages. Let's see the sum of them. First one is the biggest advantages of frequency hopping spread spectrum or FHSS is its high efficiency. The frequency hopping spread spectrum or FHSS signals are highly resistant to narrowband interference because the signal hops to different frequency band. It requires shorter time for acquisition. It is highly secure. Its signals are very difficult to intercept if the frequency hopping pattern is not known. That's why it's preferred in military services. This is the very important advantage is that it's preferred in the military services because it's hard to detect and it is highly secure. It provides very large bandwidth and it can be simply implemented as compared to the direct sequence spread spectrum system. Okay, there are some disadvantages of FHSS. There, first one is FHSS is less robust, so sometimes it requires poor it requires error correction. Okay, FHSS needs complex frequency synthesizers. Third one is FHSS supports lower data rates of 3 Mbps as compared to the 11 Mbps data rate supported by DSSS. Okay. Now the fourth disadvantage is that it is not very useful for range and range rate measurements, and the last disadvantage is that it supports the lower coverage range due to the higher signal to noise ratio requirement at the receiver. These are the disadvantages of the frequency hopping system. Now, let's see the applications of it. The first application is that the frequency hopping spread spectrum is used in wireless local area networks and standard for Wi-Fi. The second application is that the FHSS is also used in the wireless personal area networks and standard for the Bluetooth. Okay, I hope you all understand the basic idea of frequency hopping spread spectrum. Thank you.